back to the third video on transducers. So for this video, we are going to talk about the second component for an input transducer, and this is the LDR. Okay, so I believe all of you have used the LDR before in your ALP class. So this is not going to be anything new to you. It's just that for today, we're going to find out kind of exactly how we use it, and we're going to bring in some circuit analysis to it. Okay, so what is an LDR? Please underline. An LDR is a resistor whose resistance changes with the light intensity. Okay, so this is what it looks like. I'm sure you've found it familiar. And this is the symbol for a LDR. So you also have to remember how to draw this. Okay. Same thing. This is your resistance light intensity graph. So this is how it works. When it is very dark, okay, when the light intensity is low, it's very dark, the resistance is very high. When it is dark, its resistance is very high. But when it is very bright, light intensity is high, so it is bright. At very bright intensity, the resistance is low. Okay, so kind of like your NTC thermistor that we studied in the previous video. Yeah. Okay, so typically this is the range of resistance for LDR in total darkness. In total darkness, remember dark, I should have a very high resistance, and it's stated here it's more than 100,000 ohms. Indoors, indoors should be somewhere here. It's not totally bright. I get 1 to 5,000 ohms, and then bright sunlight, when it is very bright, the resistance should drop down to a very low one, typically less than 500 ohms. Okay, so LDRs are used as light sensors. In all our smartphones, we've got a light sensor. So you'll notice that your smartphone, yes, is pretty smart. In a dark room, the light intensity of your screen as compared to a very bright under the sun environment, the screen intensity changes as well to kind of tune the brightness to suit your eyes. Yeah, so that it's easy for you to see what's on the screen. Alarm clocks. Now, these are just some examples. LDRs are used in a whole host of electrical appliances and components. But also importantly, we also have to study how this works. Yeah. So it's usually arranged as part of a voltage divider arrangement. So in this case, remember, let's draw the resistance. And this time it's not temperature, but the light intensity graph. Okay. So it looks like this. When it is very dark, its its resistance is very high. But when it is very bright, the resistance is very low. Okay. So let's take a look. When it is dark, the resistance is very high. Yeah. So when it is dark, the resistance is very high. And if the resistance here is high, means it takes up a lot of energy here. The voltage across here is very high. Therefore, the V out goes low. Okay, when it is dark. But when it is bright, when it goes bright, the resistance becomes low. Low resistance. And when this resistance is low, it means that the voltage across it is decreased. It goes low as well. And if the voltage here goes low, the V out goes high. Okay, so this is how it works. The explanation for this is here. I want you to read through this example, make sure you understand it. And then over here, same thing, pause the video here at review question 8.3, try it out yourself. And then once you're done, press play again and we'll go through the answers together. Okay, welcome back. So hopefully by now you're finished trying out questions 1 and 2. All right, so let's take a look at the circuit analysis. We're going to use the voltage divider method. Okay, voltage divider. Right, so they say that the output voltage is 5 volts, so it is 5 volts here. Yeah, so they want to find out what is the resistance here. So using voltage divider method, V out, which is here, 9 volts to be shared amongst the two. This fella, 1000 out of the addition of these two takes up the 9 volts, and it's 5 volts that he has. Okay, so press your calculator, you should end up with 800 ohms. Yeah. Okay, so next one, you first have to draw your resistance light intensity graph first to kind of give you a graphical understanding of the resistance of the LDR. Yeah. So they say that the brightness decreases. So I've got to take note of this decreases. So I start off with very bright. Okay, when it is very bright, the resistance of the LDR is very low. And when the resistance is low, it takes up less energy. Therefore, V out is also low. Okay? But when it becomes dark, because the brightness decreases, right? So it's becoming darker and darker. When it is dark, the resistance is very high. So I've got high resistance. And therefore, my V out here, if I have very high resistance, the energy needed for high resistance is very high as well. Okay, so I can write my statement now. Therefore, when the brightness decreases, V out goes from low to high, therefore V out increases as well. Okay, and because they say explain as R LDR decreases. Okay, sorry, increases. It increases. Okay, so this is the second analysis and how we typically use the LDR. Now, here's a quick pop quiz for you. So right now, when the brightness decreases, V out increases, right? V out increases. Yeah, V out increases. But let's say there's another scenario when it goes from let's say for the other scenario where it goes from bright, it goes down to dark. Okay, same thing. Okay, the brightness decreases, but now I want my V out. I want my V out to decrease, but now I want my V out to decrease. What do you think I must do What do you think I must do? What can I do to change this circuit to make this so? Because over here, the brightness decreases, V out increases, okay? But if I want the opposite, I want V out to decrease instead. What can I do? Pause the video, think about it. Okay, so if you got it, good for you. If not, don't worry, let me explain. All I have to do is to switch my R1 and RLDR. Okay, the moment I switch the positions of those two, I will get the opposite scenario. Okay, it's as simple as that. If you don't believe me, do your own circuit analysis. And so with that situation, with that kind of a clue, in any situation, whether it's a LDR or a thermistor, if you want the opposite to hold true, when the light intensity decreases, but I want V out to decrease instead, all you need to do is just switch the position. Okay, so so that is LDR. Next, I'm going to go on to some other more common transducers, but that will be in the next video. Okay, so consolidate your learning for now, and I'll see you in the next video.